So this is our ACE 362 project TomaByte, and we are Team 30. TomaByte is a virtual pet that allows you to test out your capabilities without the risk of causing harm to a real pet. This virtual pet requires the user to keep the pet alive through feeding it, cleaning it, tucking it in, and keeping it happy.
To give you a brief overview on how TomaByte works, essentially there are different states that the game will cycle through, and each of these states have its own sprite animation, and some even have a sound effect that is played. The game has a health system, and this is displayed through a health bar above the TomaByte. Negative states, which are hungry, dirty, tired, and sad, will reduce the health bar by a certain amount of points, while the positive states, which are feeding, cleaning, sleeping, and petting, will increase the health bar. There is also a timer that runs in the background, and once that timer hits 0, a negative state will be triggered, in which the user will have to press a button or cover the photoresistor in order to trigger the positive event that would reset the timer and also stop the negative countdown. If the negative state is ignored, however, the health will keep decreasing until the TomaByte dies and enters the dead state.
We used 4 main peripherals for this project. First, we used the SPY peripheral for the OLED display to smoothly and quickly cycle through different bitmaps based on the state of the TomaByte pet, as well as decreasing the health bar and changing its color depending on the pet's condition. The second peripheral we implemented was PWM for the sound effects of the pet through the buzzer. The virtual pet makes a sound depending on its state, so if it's happy, it'll make a happy and high-pitched sound, and if it's sad or hungry, it'll make a sad and low-pitched sound. The PWM allows us to vary the frequency and duty cycle, creating the different tones. The third peripheral we used was GPIO for our push buttons. These buttons allow the user to interact with the TomaByte like feeding it, cleaning it, and playing with it. Each GPIO button press triggers a different event in the software, updating the pet's current state. The last main peripheral we used was the ADC for our photoresistor, which lets the TomaByte go to sleep. When the user covers the sensor, the ADC reads the voltage from the changing resistance and converts it into a number the code can understand. It basically acts like a translator, letting the program detect darkness and put the pet into sleep mode.
The PCB is designed to be small and easy to play. The dimensions of the design is 2.6 inches by 2.85 inches to make sure that the Tamagotchi can be held easily. The design of the hardware for the RP2350 consisted of 4 main parts: the voltage regulator, flash memory, crystal oscillator, and the USB for input power. The voltage regulator steps down the 5-volt input voltage to produce an output voltage of 3.3 volts that can be used for the rest of the components on the PCB. The flash memory is used to store code on the microcontroller to run. A crystal oscillator is used to provide a stable frequency source, in this case a 12 MHz frequency for the design, and an input power connection for this design was made using a USB connector. A 12-pin connector was also added to attach the OLED onto the PCB. This header is connected to the GPIO pins that are used to connect the SPY pins and the power pins of the display. Buttons are also added for the user to interact with the pet. And a buzzer is added so there could be sound component to the game, and a photoresistor is used to make the pet go to bed when it's dark.